Hi, welcome everybody. Today we're going to be covering logarithmic functions, and as you can see, we are going to start off with some vocab words really quick. Okay, the first vocab word we're going to have is called, it just is logarithmic functions. And what that is, it's an exponential function, but it's written slightly differently. So for example, a normal exponential function, we might write y equals a to the power of x, where obviously a and x are some numbers. For logarithmic functions, what you would actually do is you would say it's log and then base a of y, and it equals x. So you can kind of see what happens is, in a way, it's like this a moves over to the other side and pushes up that x to be its exponent, and then the log part kind of just disappears. The next vocabulary word is not really a word, it's a letter. It is E, and that is called Euler's constant. It is 2.71828, and then it actually keeps going on forever and ever and ever. It's kind of like how pi is a constant, but we use a letter to represent it. You know, the Greek letter pi. Here we use the letter E, and that is very important when we get into logs because of our next vocab word, which is a natural logarithm. All a natural logarithm is, it's just a log function with a base of e. So up above where we have log base a natural log would be log base e. And the way we would write that, you would actually use ln instead of log. And then again, you could have, y equals x. There's really a little e down there. Or you could write it as log with a base of e, and then y equals x. And what both of these are saying, both of these are telling us that what we actually have is we have e to the power of x, and it equals y. Again, it's kind of like that little e shifts to the other side of the equal sign, pushes that x up to be its exponent. The ln or the log, depending what you used, disappears, and you're left just with an exponential function. So that's how these are related with exponential functions. We're going to be doing it today, some examples with them, writing problems, simplifying some, and then using a calculator to solve as well. For our first set of examples, we're going to have some problems that we need to write in either logarithmic or in exponential form, depending on how they're given to us. So for the first example we're going to do, we have 4 to the third power equals 64. So what we're going to want to do is put that back into log form. Now, just to remind us, we have log with a base of a, y equals x is the same thing as saying y equals a to the power of x. So for this problem right here, what I am going to do, I'm going to kind of just write it flipped. So I'm going to just rotate how things are. So 64 equals 4 to the third power. And then what I'm going to do, for me, that's just easier to see how it looks like the standard way of a log. I noticed that this 4 is similar to the a over here. So I know that that's going to become the base of my log. So it's kind of like that's going to scoot back over. I'm going to have a log with a base of 4. The 64 stays on that side of the equal sign, and then equals. Again, if you look up at the original definition, x is the exponent, and then on the other side, it comes down and it's just a constant on the other side. So that's what's going to happen to my 3. It's going to come down, and I'm going to have log base 4 of 64 equals 3. I know it looks kind of weird and confusing, but if you guys kind of rearrange it a little, I hope you can kind of visualize how things are moving. Hopefully that makes it a little bit easier to see. And then, the more comfortable you get with these, it's just a really quick switching things around. Our next example, we are going to have log base 2 of 8 equals 3. Again, I notice that the base is going to move to the other side and push up that 3 for its exponent. So I'm going to end up with the 8 by itself. 2 is going to move over, and the 3 is going to become that exponent. And I mean, that should make sense to you. 2 to the third power does equal 8. You should be able to kind of check these things, as you go to make sure that it's right. Number 3, I'm going to do a kind of sneaky one. E to the power of 2. I'm going to do the approximately equal sign because I do have to round this, but 7.39. Okay, we have E now, which we know is Euler's constant. We learned that in our vocab. What I'm going to do is I'm going to flip it around just like I did on problem number 1. So I'm going to have the 7.39 is approximately equal to E squared. And feel free to check that on your calculator if you look, or if on your phone, if you turn it sideways, so it's the bigger calculator. E is there. Feel free to square it. What I do now is I know that this E is going to have to move over, become the base. So I'm going to have a log with a base of E of 7.39 is approximately equal, and that power of 2 is going to come down and be a regular 2. If you remember from the vocab, there is a shorter way. Instead of writing log base E, because that one gets used a lot, you can simply write ln. That's assumed it's a log with base E, a natural log of 7.39 is approximately equal to 2. That is the preferred answer for this one. And similar to how if we have base E, we can just write ln, because it's so commonly used. If you actually have log base 10, what you really would just write is you'd just write log. If you ever see log somewhere just with no base number, it's assumed it's base 10. And if you look at your calculator has log and it also has natural log. So it has log and it has ln. So that's base 10 and base 2, just so you guys are aware. Okay, we're going to get into our next example. Okay, so our next example, we are going to be solving for some logs. If you guys are taking notes with this, which I think is the best idea, feel free to pause at any time or rewind, whatever you need to do. During this example, I am going to give you guys time to solve a second problem yourself, and then come back and check with me and see how it was. Okay, so problem number 1, we are going to have log base 2 of 32 equals x. The first step that we want to do here, what we want to do is we want to rewrite in exponential form. Okay, so to rewrite this in exponential form, that's what we were doing with the last set of problems. I am going to want to take the base, scoot it over to the other side, and push that unknown value up to be the exponent. So I'm going to end up with 32 equals 2 to the power of x. Second step is pretty straightforward. It is just solve for x. So hopefully you guys remember, anytime we're doing powers, we're saying 2 to the power of something equals 32. So 2 times itself, how many times will equal 32? So you can just check it on your calculator or however you want to do it. But if I do 2 times 2, that's 4. 4 times 2 is going to be 8. Times another 2 is 16. And times another 2, that is how I get my 32. So that is 5 2's total. So 2 to the 5th power. And what that means is that x equals 5. And if you wanted to rewrite it, kind of how the original problem is formatted, you could say log base 2 of 32 equals 5. Okay. I am going to give you guys one to do yourself. Feel free to pause the video and then come back, and I will have the answer there for you to check. So we are going to do log base 3 of 81 equals x. So again, go ahead and pause, work it out, and then check back. Okay, hopefully you paused that and worked it out on your own. If you did, you should have gotten the answer of x equals 4. Okay, I talked a little bit earlier about how your calculators have regular log and then natural log. So that's base 10 and base e. If you wanted to figure out something that doesn't have base 10 or base e, there is a pretty cool formula that's pretty easy that you can do on any calculator to find the actual, answer. So what it is the change of base formula. And so what it's going to look like is if you have some logarithmic function with the base a, right? So hopefully not 10. I mean, it works for 10 and e, but not 10 or e, so that you can actually then, use a calculator to figure it out. What you want to do is you need to do log of whatever base you can do, and usually that will be 10 or e, because that's what's on a calculator. So you do log base, whatever you're changing it to, of x over, remember, fractions mean dividing, over log base b of a. I find this pretty easy to see because for me, if you look at the log base a of x, so we have x is on top, and up here, x is on top. The a is the base, it's at the bottom, and here the a is at the bottom. So I kind of like this because it's pretty easy. It lets you use your calculator to figure out any logarithmic function. So we are going to be doing this with a couple of problems, and so let's just get straight into the problems. So I think these are example 3, maybe. So example 3. So what we need to find is log base 7. Log base 7 of 3, and we need to figure out what that equals. Now, if we tried to do what we did in example 2, we'd end up with 7 to the power of what equals 3? Well, that's kind of hard to do. I know that 7 to the first power equals 7, and I know that 7 to the 0 power equals 1. So 3 falls in between 1 and 7, but I don't know exactly what value x is. It's got to be some decimal, right, that is in between 0 and 1. So this is why we would use the change of base formula. So what I'm going to do is I'm going to pick any base that I want to use. So step number 1. Okay, step number 1, we are going to change it to base 10 with the change of base formula. And then once we're done with that, then I'm going to show it to you again with base e. So you guys are going to need a calculator for this one. If you remember, if we are doing a base of 10, that means I can just write regular log, right? So what I am going to do is I am going to turn this into log of 3 over log of 7. And again, if you remember, like I pointed out at the top, 3 is the big number on top, so that's the log that goes on top of my fraction. 7 is the base, so that's the one that goes down in the base. What you are then going to do is do this on a calculator. Again, turn your calculator sideways, or find a calculator that has logarithmic functions on it online. When you do that, you get just about 0.565. Like I said, we are going to repeat the process with E as the base. So we're going to try it again with E as the base, and I'll do this one in yellow. If I have base E, that means I have a natural log. So I can do the natural log of 3 over the natural log of 7. And again, on your calculator, you're going to want to do that. You do natural log 3 divided by natural log 7. And again, you get 0.565 when it's rounded correctly. Hopefully this helps you. It's really nice to do because you can kind of use any base you want, E or 10. You should get roughly the same answer. And it's just helpful if it's something that's not as easy, like our second examples that we could do, you know, like just on our own, knowing exponents and multiplying things. What we're going to get into next is some properties of logarithms, and then we are going to use those properties to expand logarithms. So what I'm going to do is I'm going to get them all written down, show them on the next screen for you. Feel free to pause it on the next screen if you want to copy them down. Yeah, or take a screenshot of it, I guess. All right. Okay, you guys, so here are the logarithmic properties. You know I love a good squiggle box around important things. So let me just go through them with you. This white one right here, this is basically the multiplication property, where if we have a logarithmic function of 2 things being multiplied together, we can expand that out and show them as adding. The next one we have is the division one, so the blue one. If we have a log of 2 things being divided, we can separate that out and do subtracting for them. And the last one we have is if we have a log being raised to a power, what happens is that power kind of just comes out down in front and gets multiplied with log of whatever was being raised to that power. Again, I strongly suggest you copy these down in your notes so that you have them, because I'm going to be referring to them on the next screen, and you're going to want to have them so that you can look at them, so you can kind of understand a bit more of the things that I'm saying. The examples we're going to work through now, you either need to expand or simplify them. So the first problem that we're going to have log base 5 of x to the 3rd power, y to the 6th power. Now, I know that this probably looks pretty crazy, but I promise you it's really, really, really not that bad, as long as you have your properties of logs in front of you. So the first thing that we are going to do, we are going to be using the product property, and that one was the white one. So the product property, it's the one that I had written in white. I noticed that inside my parentheses, I'm taking a log of 2 things that are being multiplied together. So right here, this x and y, x to the 3rd, y to the 6th, are being multiplied. So what I want to do is I want to separate those out. So I am going to do the property which says when I separate them, it turns into adding. So I am going to have log base 5 of x to the 3rd, and I'm going to be adding log base 5 of y to the 6th. Again, that multiplying right there told us from the property that we need to split them apart and then add them. Step number 2, the last thing that I really see that is going to need to be done, is I notice that x is to the 3rd power and y is to the 6th power. So I'm going to use the power property. And what that power property told me to do, that was the green one that I had written down. It tells me that whatever the powers were, they are basically going to be moving to the front of the log and become multiplying. So what that's going to look like for the first log, x to the 3rd, the 3 is going to move in front and multiply with log base 5 of x. And then I just do the exact same thing to the other one. So the plus is still there. And then the exponent of 6 comes down in front, and I get 6 times log base 5 of y. That is as simplified as it can get. And that's the end of the first problem. I'm going to put one up here for you guys to do, and then I'm going to give you time to pause it. I'd like you to try to do it on your own, again, using the 3 properties that I wrote on the previous screen. So for this one, we are going to have the natural log of x squared z to the 3rd power over y to the 4th power. So go ahead and pause it, try to solve it for yourself, expand it out, and then come back and see what the answer is. And this is what you should end up with for this one. If you notice, when I first rewrote them, I had some parentheses right here. And I ended up getting rid of those because if you remember order of operations, we go from left to right. So that adding is going to happen first anyway. Then we would subtract the natural log of y to the 4th. So I didn't really need them. If you left them in, it's not a problem. They're just, extra. And then I took all of the powers, made them the coefficients in front of my natural logs, and that's the answer. The next one we're going to do is going to be going in the opposite order. So it's going to be written out, and then you're going to need to condense it, so simplify it down. I'm going to give you guys time again to pause and try it on your own, and then you can come back and see if you got the right answer. What this is going to be, we are going to have a 1/2, and then in parentheses, we're going to have log base 7 of x plus log base 7 of z. So go ahead, pause, try it out, and then come back. For doing this one, what I did was I first condensed the adding. Again, that was the white property of logs from, the squiggle box. I condensed it to get multiplying on the inside. So I took this adding and then put them as one multiplied together. Then the next thing, I took the coefficient out front, the 1/2 that was being multiplied out front. And because it's multiplied out front, I recognize that means it has to become a power. So it goes up to be the exponent. And then what I actually did after that was I just remembered that anything to the 1/2 power means the square root of it. So I have log base 7 of the square root of xz. Okay, that is where our lesson for today is going to be ending. There's a couple problems that I posted in Google Classroom. Hopefully this made sense to you guys. Hopefully you could understand it and could hear me fine. Please email if you have any questions. Don't forget Wednesday will be our Zoom check-in during our normal class time. And if you guys have any questions, that can also turn into tutoring time. So please go ahead, get started on the problems. Remember, you can always rewind, rewatch this and everything. Tomorrow you're going to have a small mini classwork. Should take you about half an hour. And then Wednesday, like I said, is our Zoom chat. And then Thursday is going to be a little mini test on this. Probably just 2 problems for you guys, just to make sure that you guys have been following along and are doing what you should. I hope everyone is well and healthy, and I will see you guys later.